Okay, halogenation. Halogenation mean introduction of halogen. Introduction of halogen. Introduction of halogens to any compound. To alkanes, I mean, in this case especially, to alkanes and to alkene and to alcohol and to carboxylic acid. So we can introduce halogen in these four compounds or homologous series. And overall, generally, by or with the help of sometime addition reaction or sometimes substitution reaction. So we can introduce halogen to alkane, alkene, alcohol, and carboxylic acid. That's all. As far as AS syllabus, chemistry syllabus is concerned. But we can introduce halogen by the type of reaction, by these reaction, by addition reaction or by substitution reaction. Especially addition reaction is carried out in case of alkene, only alkenes. And we can introduce halogen to alkenes by substitution. We can introduce halogen to the alcohol by substitution, to carboxylic acid by substitution. First of all, I'm going to start from alkane. For example, I'm having methane. I'm going to mix it with halogen Cl2 in the presence of UV light or sunlight. If you are not having sunlight, then you can heat this mixture in dark in absence of oxygen. In absence of oxygen. So methane, let's suppose it's going to react with chlorine, and if we are going to have exposed to the UV light, then let's suppose one of the possible compound is one of its hydrogen will be replaced by Cl. So I'm going to make CH3Cl plus HCl. This is called substitution reaction, or said to be free radical substitution reaction. Free radical substitution. So, alkane, any alkane, you can introduce halogen to any alkane. The reason is basically, we are not having carbon-carbon double bond, so we are going to make substitution. We can replace hydrogen by halogen. For example, in this case, this CH4 that is lying over here, and this hydrogen, or even all hydrogen can be replaced by halogen. If you're using limited Cl2, if you're having or using the limited Cl2, then at least only one hydrogen of each molecule is replaced. So there is replacement, there is substitution of hydrogen by halogen. So at least one hydrogen of every molecule is replaced, and there is a formation of every time one HCl as well. So in this way we can introduce halogens to the alkane. And what is this compound that has been made? It is called haloalkane. So we have made haloalkane. In all these cases, in all these four cases generally, in all cases when we are going to introduce halogen, then we are changing them into haloalkane. So in fact, indirectly, we can change alkane into haloalkane, we can change alkene into haloalkane, we can change alcohol into haloalkane, and we can change carboxylic acid into, that is not the haloalkane, that is called the acyl chloride. So these three compounds can be changed into haloalkane. For example, these three compounds, they can be changed into haloalkane. And this is changed into acyl chloride, that is C double bond O Cl group. Okay, generally once again, I can introduce halogen. How can I introduce halogen to the organic compounds? If I'm having any four these organic compounds, I can introduce halogen. Let's suppose I told you if I'm having any alkane, then I will mix it with halogen. I will keep in the sunlight, and the chain reaction starts basically, and there is a replacement of, there is substitution of hydrogen by halogen, and so on. Now the next thing is halogenation of carbon double bond. So if I'm using alkene and I can add halogen into it, yes, it is true. For example, I am going to add bromine this time. There is no need of UV light. You can perform this reaction in dark and add RTP at room temperature and pressure in dark, and this molecule is going to react with Br2. Now what is going to be formed over here? That is simple addition. Addition means when two molecules are meeting together and making single product, two molecule into one product. This is called addition reaction. So there is one Br and there is other Br. But keep in mind, if you are using CCl4 or any organic solvent, here is solvent is important. If you are using organic solvent, then there is only one compound, there is only one product, that is said to be 1,2-dibromoethane. So again, we have introduced halogen to the organic compound. This time I have made 1,2-dibromo. In first case, I made one chloro, only one chloro I was substituting over there, and this time I am substituting two. In this case, if I'm using, let's suppose aqueous medium, I'm going to write it again, once again, carbon-carbon double bond, and hydrogen plus Br2, and this time I'm going to use aqueous medium. I'm using the water in dark. So two products will be formed. One is the same, one double bond is broken down. I'm going to copy and paste it basically. One compound is quite pretty similar. Whenever I'm going to add Br2, add halogens, any halogen, and if I'm also using the aqueous medium over here, then one compound is similar if I'm not using aqueous medium. If I'm using organic medium, CCl4 or any organic or ethanol, then there is the formation of only one compound. That is said to be 1,2-dibromoethane. If I'm using water, then there is, change in the answer. One molecule is this one, and what is the next molecule? What is the next molecule that is supposed to be formed is this one. The next molecule is going to have one Br group, yes, but other OH group. One Br, similar Br, same, this one Br, same halogen. One molecule is having halogen, but the other one is OH group. This OH is because of water. So if you are adding bromine into the carbon-carbon double bond and you are using aqueous medium, then keep in mind there will be more than one product. Two products will be formed over here in this case. Number one, that is a normal one. This bond will be broken down and one carbon will get one Br. Second, doubly bonded carbon will get second Br, and this is the compound. There will be another product as well, a duplicate molecule, you can say, that is also having one Br, similarly, same Br1, one Br over here, but instead of this Br, it is going to have OH group over here. So in this way, we can introduce halogen to the carbon-carbon double bond. So I told you today, the two method of introduction of halogen. You can introduce halogen to alkanes. You can introduce or you can add halogen to carbon-carbon double bond, and so on.